I think we may have to render 5 minutes grace for latecomers.
Sorry, we'll come again. What is it? Sorry.
We have to give like. All
Okay.
right. Good evening, everyone. My name is Mr. Ebube Ugu, NAIJA-JUG admin, and I'll be anchoring today's session. Good evening, Mr. Tochiku. Okay, so welcome to our first lightning session for the month of February. We have our very own Mr. Samuel Joseph, who will be taking today's session on design patterns. So we should all do well to listen attentively. So I want everyone to react with your favorite emoji if you can hear me, to show support, to welcome our speaker for today. That's just 3 persons now. Everyone should react. Yes. Okay, that's nice. I'll be handing over to Mr. Samuel now. All right, Mr. Sam.
You still. Am I audible?
Yes, you are. You're audible, and we can see you.
Okay. Good evening. So,
Mr. Sam, you're mute. We
I'm
can't hear you now.
muted. I'm not muted.
Okay, you're not
Am I
saying anything.
muted? Okay, I'm not muted. I want to share my screen.
Okay, we can hear you now. Right on.
Yeah. Uh, okay. I want to see my screen.
Not yet, not yet.
I want to see it now.
I can see now.
Okay. Slide. Okay, so good evening, everyone. My name is Samuel Benga Joseph. I am software engineer. Software developer. So, and also manager and my colleague has Steph and also have some of the sessions. So today's session is it's lightning talks to that. So lightning talks will be light on the matter, not that heavy. So we are all learning together. So in case there's a place where I misfire, please do well to go more light, educate. So it's lightning talks. It's something I'm excited about and I want to share. But I want get to see what was going on in my head during my period of exercise. That's it. And it might be a different perception for someone. So on design patterns now, let me move. Oh, am I still audible? Sorry.
Yes, you are. We can hear you.
Okay, good. So on design pattern, so the thing that I want to clarify very much so is so we don't get design pattern confused with system design. I mean, it's one of my earlier confusions. Those two things are very different. That they're far apart. Their layers different. Their layers different. So when you are approaching your code, like when you give a problem to solve, so that's what you as a software developer, solve a problem, probably banking, a financial related problem, or a middleware service, other stuff, e-commerce and other stuff. So when you approach it, you first of all start from layers. Right? Start from the top level, the system architecture, where you are looking at the very top level. Are you going with microservice? Are you going with monolithic? Where you're making top level decisions. Then you come down to the system design, which is okay, how do I implement this architecture of children from system architecture? How do I implement it? That's what the system design does. That's what the system. Now, from system architecture to system design are very, very agnostic in the sense that they, they are not very reliant on any, they are not tied, their structure is not tied to any programming language. Then we now have the code design where we now actually real like declaring of the classes and assigning responsibilities and stuff. And before we now finally get to design pattern. Now, those responsibilities we've assigned now, how do we want them to how do we want them to scale? How do we want them to scale? How do we want them to actually communicate get? So that's already the design pattern. Now, design pattern, so I want to clear something here. It's like a proven strategy of how people have solved the problem consistently. So it's like so the list of design patterns that people have used over that works for them. So that's where these patterns are. And believe me, I think each and every one of us can get creative and mix patterns and come up with our own patterns. You get we can come up with our own patterns. You get that works for us and is very in line with the solid principle. Yeah, very in line with solid because as you write build solutions as a developer, one of the things I want to do that you should have always advise that you have mindset is in your mind or in your head. That solid principle should guide how you resolve how you approach get building a solution. Yeah. Are we still together, sir?
Yes, yes,
Are we
right on.
Okay, thank you very much. I wonder why Timile is smiling. I can see you. Okay, so system architecture. Okay, I just explained that part. The system architecture is highest level structural decisions. That's where the structural decisions are made. Then you have the system design architecture, architecting through concrete system. That's how system architecture, and then we have the whole design structure organized where you're defining it, then the design pattern. So, but if there is a question, please, if there's any question, but this is very light, so I'm not expecting a question. But if there is, please, you can ask me. So, um, system architecture again, still bringing us back to what I said. You have the monolithic microservice where you are making key decisions, deployment model gets the deployment models or CI/CD pipeline. If you still want to stick with the normal, carry your jar and go and deploy it on Linux server, or you want the proper CI/CD pipeline. Again, this is where these key decisions and there's architectural decisions again. So then we have the communication patterns. Communication pattern we'll be looking at probably Eureka, service discovery, and other stuff. Yes, REST templates, etc. So well, then the system design translate the architecture into concrete system, service boundary, API contract, the database schema, the caching strategy, the error handling, the scalability patterns. So it's how we now implement that system architecture. So from the client side up down to touching the database, the API calls, and everything. So we think in terms of scalability. So then the design pattern now. Skip the code level and straight to the code is very direct, very direct. So now we have code level proving solution that defines, like I said earlier, code level proving decisions that there are codes that a pattern that people have used for, and it's now become like a norm and a thing. Yes, they will have names for them. We have like the ones I think we have listed here like 13 different patterns, but we are only going to be touching just 3 of time, and we are going to write, we are going to code with 2, and the first one is nothing much. Yeah, so but they have like 13 or more, because this pattern are like they are man-made. Yes, they are not tied with that. Yes, they are man-made. So you can come up with your own pattern, but you just have to stick with this solid principle. And at the bone of it, there are 2 things that really stand out. Dependency inversion, dependency injection, inversion of dependency. Am I correct on that? Ebube, you can correct me. DIP.
Inversion of control, if I remember correctly.
Dependency inversion of control. Yes. Dependency inversion. Then you now have what else? You now have abstraction. Very key. So let's move. Okay, so the 3 patterns we'll be talking about here, they are listed here now. We have the strategy pattern, we have the factory pattern, and we have the singleton pattern. We have the strategy pattern, which define interchangeable algorithms. We have the factory pattern and encapsulation object creation logic, and we have the singleton pattern, which ensures single instance access. So I don't want to go ahead of myself. We'll start with singleton explanation. Like I said, there are more that, like, I mean, for me now, I think I know like 13 of these patterns you get, but I believe there are more. Yes. So patterns operate at this level of this okay. Let's touch a little bit about solid, which is one of the things I believe as a developer should be at the back of writing solution, and want to be scalable, yes, and best practice. So S stands for single responsibility, O stands for open and close. That means a class should be close to modification but open to extension. Close to modification but open to extension. Then we have the list called substitution, but that's this class. In this class should be sometimes more substitutable by that person. That means let me say a parent class should be able to substitute their child. So I think the logic would be that a mango tree should always be able to produce mangoes. That means at no point would you should the mango tree produce orange. That's when you now try to plant that orange seed, what you get orange, you get mango. Yes, so the base class should subtypes. Yeah. So then we have interface segregation. That should not depend on interface. This is also very important in the sense that sometimes you want to probably it's not coming from modified design. Probably misplaced understanding of how to implement that. So when you are implementing it, because I'll say I do this a lot. I implement, like, whenever I'm building, I just know I just have at the back of my mind that I'll create interface for my service class. But it's not always like depend on what you are building. No, it's not always necessary actually. It depends on what you are building. Yeah. And sometimes you can go off the rails to implement inside of that interface now that we're implementing the service class, you can go off the rails and implement even things that the class that will implement it will not need. You get. So the interface should be like precise as to whatever class that you will be implementing it needs those particular stuff. You get. So now we finally have dependency inversion. That means what you are doing, you are handling control over instead of tying let me just say from service layer or a client. I want to use this flow now. There's the controller and there's the service class now. Instead of tying a controller class directly to the concrete service class, you hand over the control to an abstract interface, yes, an abstract class. Yes, so you hand over that particular control. Yes. So it doesn't depend directly on the concrete class. Yes. So that's the key concept of dependency integration. It will get clear as you see some of the implications and see how sweet it is, where you don't really have to go and change core logic or change anything. Just whenever you need new features, just shoot them in and it will just pick it up. Controller does not depend on that concrete class. That's where the dependency inversion comes in. Does not, if your controller class does not depend directly on that on a concrete class. Now, whenever you want to, okay, I think when we see the code, I think we should see some of these things so that I don't say stories that are clear in my head. So, okay, this dependency inversion is high-level module should depend on abstractions, not concrete implementation. Like I said, high-level module should depend on abstraction, not concrete implementation. As you can see this screen, controller should not depend on user service implementation. Yes, controller should not depend on that user. Instead, it should depend on the user service. You get on the user service interface, which is like which is a very abstract class. So once it depends on that, now you have your user service implementation that is now your user service does not know of a controller, is just connect, just that your controller does not know of a concrete user service, it's just connected to an abstract class. Now, if you want to include, let's say, a new feature, let's say bad user service implementation, or for test case, because including interfaces helps you gives you an ease for test. Like it is good when you want to write your unit testing. So you can just create a fake user class, something like you just create a fake user class that implements this user service. So your controller doesn't need to bother itself what is going on underneath. You get it's very abstracted. Yeah. So that's one. You hand over the control onto that abstraction. So the controller doesn't need to bother itself about the concrete class that's really doing the job. So a dependency direction is inverted. High level code should not depend on concrete details. You get. So next, why user interface? So for loose coupling, why user you see, in fact, most of the 13 patterns, some does not use are not heavily reliant on interface, but most of them it's interface. You see why using interface is very important. That's why I just get to I really understand how these things work and why it's sweet. In fact, when I saw Java code for the first time, I really don't know, like, why am I declaring interface when I can just do this thing direct? Yeah, it comes to mind when you are seeing code for the first time. But over time, you get to understand why these things are very important. Yeah, and even in this pattern that we are going to see that the importance. So you have it makes your code loose coupled, that detach your controller or any service from depending on content or business directly. You get easier for testing, get flexible extensibility. So if you want to add a new implementation, very easy. If you want to add a new, you don't need to change, you don't need to go and change your user service. No, you just implement it directly and just you get with annotation, pursue naming, you get what you want. Then clear contracts. As a matter of fact, okay, I don't want to go ahead of myself. We see how Spring Boot actually even makes our life very easy with we don't see that. So we have clear contract. Clear contract defines expectation what implementing class should have. So in fact, you before a class that a service class that has an interface implemented. Whenever I'm, let's say, going to the code base trying to understand, the first place I just go to look for is the interface. So from the interface, you get to see the different methods. The business logic service class would have contained like probably 1,000 lines or so. But when you just go to the interface where that is being implemented by that particular class, you just see few lines of code and the method name and direct. You see what it is. You see what it is getting and you see what it is returning. It's very straightforward. You understand, okay, this is what this is doing, this is what this is. Very straightforward. And then framework independence. Because it stays decoupled from the scheme. Okay, this is when you look at this thing, you see that this pattern is even is very well adapted in the sense that we now have something like that. We have something like RabbitMQ, Kafka, and all this stuff. They are just improving more and more on the coupling every time. Because they like your RabbitMQ now instead of depending on the system to just fire schedule a task or push make a call or trigger something, just push it to the RabbitMQ server itself, and then the RabbitMQ settles that. So it decouples service. I'm just talking of how decoupling is now very high level. Yes, so just make work very coupling is a very big thing in the OOP, yes, and this Java programming and using Spring Boot. It's very important that you know that, and dependency inversion is a very good tool. Once you understand dependency inversion, you'll be able to grasp it. So, interface pattern, the interface enablers enable multiple implementation, unlocks polymorphism in design patterns, and provide abstraction layer for flexibility. These are more advantage of using interface. So interface make design patterns possible by defining context without. So the first pattern I want to look at here is the singleton pattern. First pattern I want to look at here is the singleton pattern. So what is singleton pattern? Let me check if I've a little bit. So singleton pattern for now, singleton pattern, there's no code base for that one. But it's just easy to understand. It's when you create like a service class and you create a service class and you make that particular the constructor of that particular class private. Now, once you make the constructor of that particular class private, it cannot be initialized anyway because it cannot be instantiated anyway. It can only be instantiated once and it will live forever. It will only one instance of that particular class will exist in that particular in that particular service or that particular application. So that's what singleton pattern really means. And now that's what Spring Boot's being. That's what Spring Boot being is like. That Spring Boot being a singleton pattern by default. Gets that single because there was a time I was thinking that is it that for every for those of us who have wondered, is it that for every request you are making to a controller, is it that the service class, if you've ever asked yourself, is the service class always instantiated? Yes, I think the problem I arose, and I had to ask myself that because there was a variable within the class, and I thought the variable would be new every time a call is made to that particular service. But it is not instant. It is not. No. The service class is not based on how things are being handled by Spring Boot. They are singleton by default. they don't instantiate anything anew. You get, so that service class will live forever as long as that application is running. You get, and it will only be one instance of that thing. But notwithstanding, you can remove the control from Spring Boot and then create your own constructor. You can do that, but it is not advisable. It means you have taken over the control of that particular service class of Spring Boot, and it will not manage it, and it cannot even be called a bean. But bean is an instance of a class that is managed by Spring Boot. Yeah, that's what beans. That's what that beans is. That beans are. Yeah. So advantage: it reduces memory footprint, manages shared resource efficiently because there is just one instance, and hidden behind interface abstraction. So these are even by default without you actually using them. As long as you're using Spring Boot, yeah, it is there by default. Your service class is Singleton. As long as it's an instance managed by Spring Boot itself, it is Singleton by default. So the next one we want to any question? Any question?
Right on. Okay.
Thank you very much. So it's a very light topic. So okay. So next one I want to talk about now is the factory pattern. Now I really love this pattern. When I discovered, I was just jumping in my heart. So I really love this pattern because in core cases, like when it really matters, it really simplifies and makes your work very neat and very professional. So we'll do a little bit of coding for this. I already have the code base, but we just do some tests and so what factory pattern actually does? So so what factory pattern is now if you check this diagram, there's the client. Let's just say call the client the controller server that calls that the controller or the client that, let's say the client wants to yeah, the controller, which is the point that the client interfaces. So now whenever you want to, it abstracts your interface or implementation in your service layer and makes it very decoupled in such a way where whenever you like let's say you want to uh, make a for example now, let's say you want to build a system that can take card payment and PayPal payment, can take a payment through card and take a payment through PayPal. Now, what you just need to do is to create a payment factory and an interface where that has credit card process and PayPal process, and then you plug it into that PayPal process interface. And then what you now do with the payment factory, you will now create a map. We're just going to do so that you see what I'm talking about. Okay. I want to see my phone.
Yes.
Okay. Let's see. Okay. So let's start from the interface so that you see what we're talking about. So we go from the payment process. Now, this is just a simple interface, a simple payment processor. So you can implement PayPal, credit, and any new payment process that you want. Probably I don't know, credit card payment, PayPal, software, whatever type you want now. Whatever type you want. Now you do your normal, you implement those services. You have your PayPal processor here. You have a PayPal processor that implements that particular interface. You can see you have your payments. What it does is return PayPal payment process. And you also have another one which is card credit card payment process. And now note the component, there's a name at the top of this component. There's a name at the top, so you are giving this particular component a name for Spring Boot to recognize it. So it is called credit card. It's called credit card, and it's called credit card, and for PayPal is just PayPal. Yeah. So now, where the payment factory now comes in now, look at what it does for us now. The payment service now. Look at this simple line of code. Just this simple line of code. What Spring Boot does with this is that it now takes, it loops through your code and the interfaces that implement that particular interface payment processor, and it creates a map based on that particular name that we've given at that name that we've given at that particular this component name that we give. You get. So Spring Boot does it automatically. You didn't do anything. Once you just do that, Spring Boot takes care of so Spring Boot takes care of the mapping for you. Put the name and the type of payment process that is attached to it. So for credit card processor, it will map this one. For PayPal, it will map this particular service. So now, how do you implement? Now your implementation just call your payment process factory. You inject your payment process factory inside of your other service. Then what you just pass the name of that particular service that you want. If you want to pay through PayPal, you just put PayPal and it will pick that particular service. If you want to pay through credit card process, a credit card, it will pick, you just put the name and you pick that particular service. So if you want multiple service, if you want more service, you don't need to change anything. You just include that service and you pick it up. You see how easy it is. So if you want, let's say more clients, or you are integrating more people, just more payment gateways, just include the service, and that's all. It's just pick it up for you. So let me okay, Balogun, sorry, you want to ask a question? Go ask.
Oh, sorry. Just to be sure, last question. It would be at the end of the lecture, because I have a question that is like right now. So if that is permitted.
Okay, please ask your question. If I can't answer, I will throw it to the house.
Okay, yeah. So I want to just take a look at the get processor method, what the content looks like, so that I can thank you. Just the get processor method.
Get processor.
Yeah, line 13 on order service.
Okay, that's it. Okay, this get processor.
Yeah.
Okay. That's in the payment factory. So this is it here. So once you pass the type, it's a map. This is a map. So .get, just taking the type. Like I said, what creates this map for you? You see that in this code, there's nowhere where we manually add those services. The Spring Boot, once you run it, the Spring Boot just automatically populates the map for you. You get, so just a normal plain old. Once you just pass in the particular name of that service, which you have stated here at the top of those services, we name them credit card, and for PayPal. It will just pick it up and load and return that particular service for you, that particular interface implementation for you. So, but if it does not, if it does not exist, you have already. If that particular type does not exist, there's a there's a exception handler here. It's just put, okay, this particular process does not exist. But with this now, there are lots of things you can do with this, because now once you build your system like this, when you are integrating more payment gateway. You don't have to change anything in your code. Just create that particular service, and the Spring Boot will pick it up. Okay, so let me run this part. Okay, I have a controller here already. So what this will do, once you are paying through any payment gateway you want, if it's through PayPal or normal credit card, you just pass in that particular type. You just pass in that particular type, and it will pick it, it will process it through that particular service. So I will add one more service, but for now, let's just see how it runs. I don't know. Olakole, I don't know if I answered your question or you seen it.
Yes, yes. You did.
Okay.
Thank you. Thank you.
Okay. So let me just. Let's take it. What is this? Yes. What's this? I don't know why it's not taking time. I think I should close my page. Okay. 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 It is running now. So I just go to my. I already have a Swagger implementation. Yes. Okay. So once you process order, what you just need to supply is for PayPal. If you want PayPal, then you supply the amount. Then it uses the PayPal. See PayPal payment process. So if you want credit card, use credit card and it processes it. Credit card payment process. It picks it up automatically for you. If you use something that does not exist, just through tutorial and everywhere always know and let me now let's just to see how simple this really makes your work. Now when you want to add another payment, let's say is it paystack? Let's say float away. It's just simple straight. Let's say paystack paystack processor Java. This good. Okay. Let me just What? No, for some system. Oh, how is this happening? I think I should put this. Okay, so I'll change this to this. Yes, 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 this. Okay, think with this, don't need to change much. Ah, yeah. No, sorry about this. Okay, I think that's good. Okay. Okay, now let's try without changing into let's try this back. See. Oh, so you can see that it's just process space tag. Just process space tag straight away without changing much. You just add, you just plug in the service and you just fix it up. So that's that. You can delve more into that particular pattern and can do a lot with it and do very much a lot with it. So Any question before we dive into the last pattern and then it's almost time. Any question? Okay. Am I still audible?
Yes, we can hear you.
Okay, okay. Thank you very much. Okay, so strategy pattern now. This is also very, very this is also a very good one actually. So what this does is it's like the factory pattern, but it removes that it removes it's like a factory pattern, but it removes that factory, and it's also applicable for different situation. You get, but the patterns are very similar. They are very similar in the sense that you can plug in new services as much as you want to get. So, but for this one now is that it's 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 it makes your work very dynamic in such a way that, let's say for the case study now that we're looking at, want to get like the best the best discounts for a particular customer, and then let's say there are loads of logic to actually uh, consider before giving a particular customer a certain discount. And then each customer can qualify for any of these discounts, but you want to give them the best that they are qualified for. Yeah. So now, one of the ways you want, for scalability, you want to separate this logic into different services. Okay? So, because in future time, maybe there might also be other considerations to get. So, now the code base we'll be looking at, we'll be considering discounts, best discount strategy, like best discount for a particular customer here. So it looks through, you hand over just like the map, or not like the map. You are using for map for the previous pattern we just worked on. This is factory pattern. Use the map, but for this one you're using a list. So, but it's still handled by the Spring Boot. The Spring Boot will look through the service and calculate the best and calculate and return and make use of the service, or return the result of the service with the best discount for a particular user. Yeah, so the Spring Boot is looking to get the best results that you want. So in some cases, like this particular use case, it is very important here. You get, in the sense that in future you want to consider other variables. I want to create other service for that could qualify a particular customer for a certain type of discount. These things can get their loads of different logic, and you just want to make your code as simple as possible. If you are considering the solid principle, you want to make sure that this particular class is doing just one, and you get so, and make your code very, very. So let's just go into the code base. Let's go into the code base. We'll see what's going on. Okay. So just like the factory pattern, the strategy pattern, we start with the interface. The discount strategy starts with the interface here. Yeah. We start with the interface. Start with apply discount. The interface, just one method. I just had to shrink it. I just have to shrink the logic down, but the logic is very convoluted. I just have to shrink it down so that so it applies discount based on the amount that is passed to it. So now we have different services now that now have the new user discount. That particular user will be a new user, and about that new user is also a premium member. You get, so you want to apply the base discount for that particular user. You get, so you now have to two different services that implement that particular discount strategy. So we have the new user discount. So the discount, we just add code everything. So we are looking at the discount is 50. Discount, so whatever the original amount is, the discount will be probably, if the person supply $100, the discount is minus, it will be $50. So the person will be paying $50 to get. So for the premium, we have $15 discount. So if the person is paying $100, the person, if the original amount is $100 for that particular course, the person will eventually pay $85. So very simple and straightforward. So then we have this is now how we implement discount service. So like I explained, it uses, unlike the previous one that implements with map, where we have to specify names. This one just just use list, and the Spring Boot itself will just pick those any of those services that implements it and populates this particular list. It populates this particular list for you. So we also have in this particular service, we calculate the discount. Now, if we check find best discount service, you see we are looping through that particular list. So it will look through that particular, and the results that a particular service gives you, it does a compare and check, okay, which one is the best discount, which one is giving us the best discount, that is the best discount, which one are we paying less, right? The highest discount, which are we paying, which of the discount are we paying less for? So it now returns the result of that particular discount. That's the logic here. So when we run this code, we have the controller already. So the controller is just taking the amount, the original amount that's paid. So let me run. And this with this also you can there's the new user discount, there's the premium user premium member discount. You can also add more discount like old user discount, etc. etc. It's very easy to plug in, and the Spring Boot will just pick it up for you. So because of time, I think I'll just do this example. I'll try the code base will be available. Can try and plug some more service, some more service, and see how it works. Okay. Okay. How is this feel? Exception. Am I? Oh, sorry. I did not. I did not show down the previous. That was not sure. So the beauty of knowing multiple, like trying these design patterns, it gives you like a well, like already tested solutions to some problems you most likely face when you are solving real world problems in probably your organization, and you're taking of the best pattern you get. Like one particular solution that I was bugged with one particular time was a scheduler, and Then the way I eventually solved that particular problem led to cyclical dependency. But had it been there's sufficient knowledge of design pattern at that particular point, it would have been easier to solve, because eventually I was able to solve it by doing lazy dependency, by causing that particular cyclical dependency. But I believe like a tested design pattern would have been able to resolve that very more efficient. Yes, I really don't know why you should. Like, if your design pattern is well structured, you shouldn't have a cyclical. Okay, so want to calculate first. So the amount put on it, then the best will be 500. 500, because what we have, okay, the discount is 500. The best, yeah, the best discount is 5. Which one is it? 50. Okay, so in percentage, yeah. So we are taking 50. 50. This is 50 is like 50%. But you are paying half. You are paying half. So it's picking this particular one. So if I'm to, let me reduce this to let me reduce this to 5. We start. So you see that it will pick the premium. The premium is 15%. The premium is 15% discount. So for 1,000 we'll get 750. We'll be paying $750, yes. So as it loads, if there is any question, because I believe our time is fast. So if there is any question you can ask. Are there any questions?
So everyone understood.
Everyone
And I think your teaching was very clear.
very clever. It's light, very light. Okay, so
Okay, you can write on.
yeah, so once I execute, oh sorry, my calculation is, so that's 15%. Let me take 15%. That's $850. That's 25% that will give us 700. So that's for the premium discount, which is 15%. So that's why we got 850. So it is picking the premium. So it is very easy once you change, although you don't have to code it this way. Yeah. So, but that's that for the you can try and test the waters and see how far you can move. So there are a lot of things. This is just like standalone, just testing. So there are a lot of things, and there are ways to make your system very robust and very scalable. That's the key. That's the key thing. Very scalable. So there are different. So so we have, okay. So system architecture design, system shapes, system, okay, that's just a recap. So good software is not about avoiding change, but controlling it. You get, not about, in fact, the first one we did, which is the factory pattern. You see that I didn't do the exception was properly. When you provide something that does not exist, you get, it doesn't just break. You get, it controls it and gives you, okay, this particular service. You get, So whatever you are going to pay with, but just plug it in and it's just pick it up from there. You get. So good software is not about avoiding things, but controlling those things. So this particular decoupling method gives you like a very good control over your system. It doesn't break anyhow, you get. So and lastly, there are like lots of there are other design patterns that you can check out. There's abstract factory patterns, builder pattern, chain of responsibility pattern, command pattern, state pattern, prototype pattern, adapter pattern, decorator pattern, observer pattern. Yes, you can check these things out and try it in your code, and your code will look very, very clean and very professional, like a senior engineer type of. You get. It makes your work very easy, and just it even makes your life easier as a software engineer. You don't have to be changing everything, changing everything. Just come and just plug one thing and you're done, based on the way you arrange. So it's more like a paintbrush to paint something very scalable, very steady to get. So that's me for today. I hope, yeah, okay, they say they understand what I've said so far. But that's good. Thank you all very much for hearing me.
Let you, Mr. Sam, love next emojis. I personally learned a lot from this session. I think the most surprising thing to me was this factory pattern. The more common like it, the more common ones like the data pattern, the solidity pattern. I personally learned that the factory pattern used to be
Hello, Mr. Ibuwe. Yeah, you can continue. I'm done, sir.
Okay, so now
Hello, Ibuwe, we can't hear you if you are speaking. Sorry, can anyone hear Ibuwe?
No, I cannot hear him. I think his voice is just. I can hear him.
Okay. Okay, I think I should wrap up. Okay, let me just wrap up. So, thank you everyone for making it to the session. We really appreciate your presence. And yeah, that's all. So, another Tuesday from Tuesday will be very powerful. I think I have insight as to which even place. So, so be ready to be amazed on Tuesday. Don't forget next this Saturday we'll be having our DSC. We'll be having our DSC 8:30 to 8:30. That's we want to so thank you very much. Have a wonderful night.